Welcome to Easy BTech, your guide for BTech and beyond. In the today's topic, we will discuss regarding the analysis of a transistor amplifier circuit using H parameter. Simply, we will say as a H parameter analysis or small signal analysis using hybrid model. Okay, students, we will draw the equivalent circuits and we will find what is the current gain, voltage gain, input impedance and output admittance. Okay, students, today we will discuss analysis of small signal network, or simply we will call as small signal analysis or small signal analysis. Okay, students, we will say a two-port network parameter. Now it is a two-port network. Two-port. It is an input port. It is an output port. It is a common grounded. Okay, students, here we will give the source resistance Rs, and here we will write as input voltage source Vs, and it is connected to the load resistance RL. RL is the load resistance. Okay, already we know the H parameter analysis. From the equation, V1 is a function of I1 comma V2 and I2 is a function of I1 comma V2. This we will write V1 is equal to H11 I1 plus H12 V2. I2 is equal to H21 I1 plus H22 V2. Okay, we will rewrite as V1 is equal to Hi I1 plus HR V2, equation 1. I2 is equal to HF I1 plus H0 V2. This all we have studied from the previous equations, the previous analysis. From this, by considering this, we will write the equivalent circuit in the hybrid model. That is Vs, source resistance Rs, input voltage here to here we will call as a V1. This is V1. V1 is equal to this is Hi and input current I1 and HR V2. This is V2 HR. And this current here, current source I2 is equal to HF I1. This is HF into I1 this is H0, output voltage V2 and the load resistance RL. This is a small signal equivalent circuit. Small signal equivalent circuit. Okay, by considering this, we will find the first one is current gain AI. Represent a current gain. Output voltage I2 by I1. Output current by input current. From the previous circuit, the output current is I2, input current is I1. This we will write as, therefore I2 is equal to minus, then simply we will write current gain AI is equal to current, this is a reverse direction. If you see here, this current direction is reverse, that is why we can represent minus I2 by I1. There is a current gain. Current gain of a small signal analysis is AI is equal to minus I2 by I2 is equal to minus, because of reverse direction of current. That is, we will write I2 is equal to, from these expressions, from the equation 2, HF I1 plus H0 V2. Therefore, output voltage V2 is equal to, we will write this I2 into RL. V is equal to IR formula. We will write, therefore V2 is equal to minus I2 into RL. This will substitute in the V2. I2 is equal to HF I1 plus H0 minus I2 into RL. This we will write I2 HF I1 minus H0 I2 into RL. If this will go this side, then it is I2 plus H0 I2 RL is equal to HF I1. From this, we will write I2 common, 1 plus H0 RL is equal to HF I1. From this, we can write I2 by I1. I2 by I1 is HF by 1 plus H0 RL. This is I2 by I1. This is I2 by I1. But already we know that is AI is equal to minus of I2 by I1. That is minus HF by 1 plus H0 RL. This is the current gain. Current gain. Similarly, if you find input impedance Zi, we will call as an input impedance. Input impedance for our Ri, input resistance. This we can represent Zi is equal to V1 by I1. V1 we will write as, from the equation 1. From the equation 1, V1 is equal to HI I1 plus HR V2. V1 is equal H1 I1 HI I1 plus HR V2 is it divided by I1. Next HI I1 by I1. I1 will get cancelled plus HR in place of V2 we will write as minus I2 into RL by I1. Okay. Zi can be represented as Hi plus HR. This minus I2 by I1. This is AI. We will write AI into RL. This is the input impedance. This may also written as Zi is equal to Hi minus HR HF by 1 plus H naught RL into RL. This is also input impedance. This is an input impedance. Next we will say current voltage gain AV is equal to V2 by V1. V2 by V1. Now already we know V2. What is the value of V2? Therefore, V2 is equal to minus I2 into RL. Minus I2 into RL by V1. From this minus I2, therefore, we know that current gain AI is equal to minus I2 by I1. From this we write as minus I2 as AI into I1. Just cross multiple. In place of minus I2 write that AV is equal to AI into I1 into RL by V1. AV is equal to AI RL by V1 by I1. This will come to denominator. AV is equal to AI RL by ZI. This is the voltage gain. Next, we will find now output admittance. Output admittance. Output admittance is equal to output current by output voltage. Okay, therefore we know that I2 is equal to HF I1 plus H naught V2 divided by I1 divided by V2. Then we will get I2 by V2 is equal to HF I1 by V2 plus H naught V2 by V2. V2 get cancelled. You will get at HF I1 by V2 plus H naught. This is the value. To get this ratio, therefore, to get this ratio I1 by V2, okay, from input side, from input side of equivalent circuit, that we will write as this is source Vs, this is the resistance Rs, and you are having HI I1 HR V2. This is an input side equation. Now apply the KVL. By applying this KVL, we will write Vs is equal to I1 into Rs plus I1 into HI plus HR into V2. Therefore, input is open circuit, Vs is 0. Then what you will take? 0 is equal to I1, if you take common, Rs plus Hi plus HRV2. Now we will take this equation as minus HRV2 is equal to I1 into Rs plus Hi. This we will write I1 by V2. I1 by V2 is equal to minus HR by Rs plus Hi. This is the value of I1 by V2. Now this value you can substitute in this equation. I1 by V2. Now what you will get? Y0 is equal to I2 by V2 is equal to H0 plus HF I1 by V2. That is H0 plus HF, and I1 by V2 value is minus HR Rs plus Hi, minus HR Rs plus Hi. This we can write as H0 minus HR HF by Rs plus Hi. This is the output admittance value. This is the output admittance. Okay, you will get the values. Remember, AI is minus HF by 1 plus H0 RL. ZI is HI plus HR AI into RL. Next AV AI RL by ZI. Next Y0 H0 minus HR HF by Rs plus Hi. These are the four values. Okay students, these are the current gain, input impedance, output impedance, output admittance, and input current gain, input impedance, voltage gain, and output admittance. And typical H parameter values you can see. Now typical H parameter values you can say. Suppose for common emitter, these are the three cases which is a common. For example, for common emitter, means common emitter means emitter is grounded. Now this is the case. This is an input, this is an output, this is a common emitter. For this the equivalent circuit is HIE input Here V1 is VBE. Here it is HRE, output voltage VCE, input voltage is IB, and HFE, input current is IB, H0E and load resistance RL, and output voltage VCE and output current IC. Okay, from this we know the voltage here to here is VBE, input side is base, current is IB, output current is IC, output voltage is VCE. Now to write this H parameter equations, we will write as VBE is equal to HIE plus HRE VCE. It is an equation 1. IC is equal to HFE plus H0E VCE. It is an equation 2. For common emitter, remember approximate values. HI value may be 1.1 kilo ohm. HIE value is 1.1 kilo ohm. Next, HRE value, that is 2.5 into 10 power minus 4. Next, HFE value will be 50, and H0E value is 25 microampere per volt. These are the values for a common emitter configuration. Similarly, common base configuration. For common base, we have the base is common. It is a base. Base is grounded. It is emitter. Input current is IE. Input voltage is VBE. Output is IC. Output voltage is VCB. This we will write as HIB, IE, HRB, VCB, HFB, IE, H0B, VCB, load resistance RL, output current is IC. VBE. And this equation, H parameter equation, VBE is equal to HIB plus HRB VCB. IC is equal to HFB plus H0B VCB. And this value typically, input impedance is very low. Input impedance for common base is very low, that is 22 ohm. Next, HRB, there is also 3 into 10 to the power of minus 4, and HFB, that is HFB means current gain. For common base, the current gain is less than unity, minus 0.98, and H0B, its value is like 0.49 microampere per volt. This is for the common base. For common collector, Collector is common, output terminal is emitter, collector is grounded, base, VBE, IB, IC, VCE. Okay, this HIC, HRC, VCE, VBE, VBC, VBC. HFC, ISP, H0C, load resistance RL, VCE. This H parameters VBC is equal to HIC, IB, HIC, IB plus VBC, HIC, IB plus HRC, VCE, IC is equal to HFC, IB plus H0C, VCE. And this value typically input impedance is high, HIC is 1.1 kilo ohm, H0, HRB, HRC is 1, HFC is minus 51, H0C is 25 microampere. Okay students, Easy BTech guide for BTech and beyond. These are the values of H parameter analysis. Thank you.